Hi students, welcome to World of Maths. Hope all are doing good. Today we will continue the chapter 1 real numbers. The next topic is revisiting irrational numbers. What are irrational numbers? We all know the numbers which cannot be written or which cannot be expressed in the form of p by q, where p and q are integers and q not equal to 0. Irrational numbers are numbers which cannot be written in the form of p by q, where p and q are integers and q not equal to 0. What the examples of irrational numbers are square root of 2, square root of 3, number pi, etc. To prove the irrationality of numbers, we need to know one important principle which is based on the fundamental theorem of arithmetic. The important theory is, let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. I know this is a bit confusing, but if we put numbers into the formula, it is very clear. So let's p be a prime number. For example, if we take 3 here, and if p divides a square, and we are taking like if 3 divides 9 square, then 3 divides 9. So the theorem is, if p be a prime number and if p divides a square, then p divides a also. Now let's prove the irrationality of square root of 2. To prove the irrationality of square root of 2, we are using a method called method of contradiction. Initially, we will assume square root of 2 as a rational number. What is a rational number? A rational number is a number which can be expressed in the form of a by b, where a and b are co-prime. So we are assuming square root of 2 as a rational number. I hope you know what are co-prime. Co-prime are numbers which have only number 1 as their common factor. So square root of 2 can be expressed as a by b, which can be written as square root of 2b equal to a. Squaring both sides, square root of b whole squared is equal to a square. Simplifying, we will get 2b squared is equal to a squared, which tells that 2 divides a squared. If as per the previous theorem which we have seen just now, if any number divides a square, then 2 divides a. Let's assume a is equal to 2c, where c is an integer, and substituting the value of a in the first equation, we will get 2b square is equal to 2c whole square. Simplifying, it is 2b square is equal to 4c square, where b square is equal to 2c square, and we can say that if 2 divides b square, then 2 divides b also. Now we have proved that 2 is a common factor of a and b, which contradicts our first assumption that a and b square root of 2 as a rational number. Initially we said a and b are co-prime. Co-prime are numbers which has only number 1 as their common factor. But we proved number 2 is also a common factor of a and b. Hence, our initial assumption, which is square root of 2 as a rational number, we failed to prove the initial assumption that square root of 2 as a rational number. Hence, we can say square root of 2 is a irrational number. Now, let me explain this again little more detailed and also in a simplified way. As I said, to prove square root of 2 as an irrational number, we use a technique called method of contradiction. The first step is to assume square root of 2 as a rational number. Then we can write as square root of 2 is equal to a by b, where a and b are whole numbers and b not equal to 0. Also, we need to assume that a by b is simplified as co-primes. Co-primes are numbers which have only 1 as their common factor. In order for a and b to be in the simplest terms, both a and b cannot be even. We all know if a and b are even numbers, we can again simplify that too by dividing by 2. So to be A by B to be in the simplest form, both of them cannot be even. Either A or B can be even, but both cannot be even. So square root of 2 is equal to A by B. Squaring both sides and cross multiplying, we will get A squared is equal to 2B square. So the square of A is an even number because it is 2 times of some other number. So if A is an even number, then A has 2 as its common factor. As we know, if any even number will have 2 as its common factor. Now let's assume A is equal to 2C, where C is this other number. Now the contradiction happens. We substitute A is equal to 2C in the original equation. Then we will get 2B square is equal to 4C square, which is B is equal to 2C. This means that 2 divides B square. So 2 divides B also. This means that B is also even and B has 2 as its factor. So now we have arrived that A and B has 2 as their common factor. Our initial assumption was that A by B was simplified to its co-primes, and now it turns out that A and B both would be even. Now we ended at a contradiction to our initial assumption. Thus our original assumption that square root of 2 is rational is incorrect. Therefore, square root of 2 is an irrational number. I hope you are clear on proving the irrationality of numbers. Thank you for watching. Please do like, share and subscribe and click the bell icon so you will not miss my videos. Thank you.